lights here. And what do I just refresh? No, it says I'm online. No, not offline. Oh my goodness. Okay, it's just that one's wrong. I want this one, right? There we go. Look at that, extra ad. All right, let me go turn off some lights. You did like half the last time. Oh,
Yeah, I think it's that one over there.
Got to explore that side. It's doing half the lights before. Oh, okay. That one, but not the other one?
Wait, try turning that one off. And then. Oh.
This is not like this.
This is half? Okay, no, I felt like we had the other.
We definitely had darker left.
Yeah, fine.
So I'm fine with them being all the way off if you guys are, or if you'd rather have them on. Whatever helps you see better. Should be fine. Yeah, I'm watching. Okay, good. There, now I got chat. All right, welcome on back. So we finished up the course introduction, started working on some tools, and then my laptop freaked out. So sorry about that. I think it's working better now. So we'll finish up our tools review. Last little bit of review of Java. I want to go over the lab one more time. I think most everyone got it. A couple of you are new to it, so apologies if you've seen it all before. But we'll walk through that one more time. Right, so first thing you're going to do is grab the Classroom GitHub link, and that will ask you to accept the assignment if you haven't yet. Once you've accepted it, you can always go right back to that link. It'll take you back to your repository. And then we're going to use the code button here to open with GitHub Desktop. If you don't have it installed, it'll ask you to install it. Otherwise, it'll just open up so you can clone the repository. I've already got it cloned. You'll just hit accept or yes, you want to clone it. It'll put it in your default location, great. If you don't want it in the default location, that's fine too. And then you can view on GitHub to launch back to the website, or show an Explorer to open up the File Explorer viewer so you can see inside of that folder, that directory. Those are our best two shortcuts here. Now, you're always going to get a main.py that comes with the template. So when we fire up Pycharm, we're going to start a new project in that directory. I have one here already, right? So this .idea folder is all the Pycharm files that show up there. So I've got a project already. You can just start a brand new one in that directory. So we're going to do one folder, one repository for every assignment, for every lab. We'll keep things nice and clean. I think it'll work out best for us. So you'll just end up with a lot of folders like I have in this GitHub directory. You just get a bunch, and that's okay. Lots of folders are fine. They'll keep things organized. And if we can ever get Pycharm to launch. Hey, Unknown, thanks for joining online. I gotta remember to keep looking up for chat. I can do this. I can remember to look up. Maybe Pycharm will load. There we go. All right, so this was where we were left off with the examples. So any of the code that I write in class as example stuff is going to go out to the main course repository. I don't think, did I actually link that out for you guys? I don't think I linked it yet. I'll add that one. Just add it here, I guess. Add another link. Course repository. Look at that, it's already spelled for me. And it'll take you right here. So all the code we do in class will show up in this same repository. Hopefully that'll make life easy to go find. Definitely load that one in the new tab. So you got the syllabus and the course repository out here in Canvas that you can go find. So I'm going to start up a new project, file new project, and you want to make sure you pick the location of where we're going to put it. So right now, mine's looking at this folder. Pycharm likes to just give you a Pycharm projects location. You want to make sure you get it in the GitHub folder. So change and go browse. This browsing is a little bit annoying, but that's okay. So we'll go 2001 lab 0 for lab 0. If you already have a Python interpreter, great. If you need to make one new one, fine, but you don't need to do a new one for every project. I'll just spend extra time copying Python files over for you. So I set up one new one one time, and I just put it right at the root of GitHub. So all my projects can share it. So that's the one I already have here. So if you go through that step, great. It doesn't hurt anything to copy every time, but it's a little easier and faster to just use that one. And the main PY, we already have a main.py file, so that won't actually do anything for us. We say create, it'll say, hey, do you want to do it from existing sources? Because you already have stuff there. Yeah, let's do it from existing sources. And I want to do it in this window. I usually only have one Pycharm open at a time. My laptop's already slow enough, I guess. So we can open it up. You've got the README file. We'll leave that one alone. We don't need to bother with the README file, but we want the main.py file over here. And this is where we dump all of our code. Just a bunch of print statements for the first lab. You can make a change here, right? We can add another print. Let's, try this again. And I need double quotes here if I want to use apostrophes. There we go. Okay, give that a save. Now GitHub will see, Git will see, hey, something's changed inside of this lab 0 repository. Great, main.py. So if this other stuff changed, anything inside of the idea changes, just let it change. No big deal. So main.py we see, we added the new line. It's green here. So great, we give it a commit summary. So here's add 0 again, commit, and we push that one out. So commit will make the changes locally on my copy of the repository. Push will then synchronize with the cloud repository on github.com. I want to make sure the change is made it there, right? Use this repository menu, click view on GitHub, repository, view on GitHub, and it'll relaunch out to the website, and we can go look at any of those files and make sure they look like we expect. So if I go check out main.py, it'll just open it up again for me, and I can see, hey, we've got the stuff I'm expecting here. Life is good. Okay. The other reason I really like using these tools is we get these automatic pull requests. We'll spend more time talking about that today as well, how you would do this without the GitHub workflow, especially if you are going to work in pairs on that final project. This will save you a little bit of headache here to follow some of this workflow. So it opens up what's called a pull request to say, hey, I want to make a bunch of changes here to that main branch. So I want to keep main safe and working and not breaking anything in main. Generally, it's really bad form if you break main, because then stuff stops working. That's fine. So you can go over to files changed, take a look at all the files, and right in here, right, we can leave notes at individual line levels about stuff that's changed. So you can leave feedback and say, hey, why don't you change this before you go make these changes? They can go and update and edit things, and all that workflow can happen inside of our web tool here, which is fantastic. That's it for lab 0, right? So we'll turn that one in. Lab, I forgot to check if I can remote. Let me leave myself a note. Check in to the Unix server from home. I think you can, but you might need to be on the VPN. You probably need to be on the VPN. Have any of you looked at installing the VPN? I don't know if they just do that for staff or faculty, or if students can get on it. I think you can. Or VPN. Let's see. Let's see what it says. That's the wireless VPN. Maybe. Oh, students, yeah. Okay, so you'll be able to set up the VPN if you need to get onto the network. So I'll double check to see whether or not we'll need that, or if it's just open. Kind of be surprised if it was, but we'll find out. It'll get you on the network, and then we can connect in with some tools to get onto the Unix server, we can run our Python code on the Unix server, use the terrible editors in Unix land where there is no graphical user interface. We'll feel proud about ourselves. We can brag about it later that, yeah, I've suffered through using VI. And then we'll never touch Unix again, at least in this class. But, you know, expose you to it, have a chance to play around with it. It's a little bit of fun just to have done it. Unix is another operating system. So like Windows is the Windows operating system. Unix is just another flavor of operating system. It's got a whole history. I don't usually bother lecturing about it because you can just go to like Wikipedia and look it up. It is quite popular. Not user-friendly though, so it's not for like personal computers. A lot of servers will run Unix and things like that. But yeah, it's not too bad. Right, so there's my little note. I'll figure that out later. Right, so that's it for the lab. Lab Monday again will be the Unix lab. We'll practice that one. I'll let you know if we can do that one from home or not. And then moving on forward, we're going to jump into chapter 2 next week. So we'll spend the rest of today looking at some of these Git workflows, a little bit of Python review, and we should be good to go from there. Let me double check. Yep, and that's all we've got in the schedule. So, and then we'll just keep on going from there. So we'll pick up our first individual project after chapter 2. We'll start our first project there, and then that'll be due in 2 weeks. We'll get to here. We'll do our next project from there. We'll get into stacks, queues, and dequeues. Do our next project. Probably wait until after the midterm to do the next project. So we'll probably just pick it up this week, and then we'll have our last project this week. That gives us the last month. So if we start our final project in April. So it should be about every 2 weeks for a project. So on week 2 and 3 for a project, 4 and 5 for a project, gets you done so you can get the midterm, spring recess out the door with nothing to worry about. We won't have anything to do over spring break or middle of winter break still. It's not really spring. It is March, but and then we'll pick up the last project, third project, fourth project, and the final project then will be all of March, or all of April. And, oh, did I not update this one? I'm sorry, I updated my Word document here. Must not have updated it. This one here. Let me go update it in Canvas. I thought I did. Not have. We found Tuesday the date for our final exam, right? We're the 28th, I believe. We're the 28th, 3 to 6 p.m., right? I think that's right. Make sure I got the right version here. Yeah, okay, so 28th. So that'll give us basically all of April to work on this. So hopefully it'll be good, because that is the largest portion. And individual projects also make up that, but there's 4 different projects versus just one final project here. And I'd like you to work in pairs. That's our goal here, that we're doing this as part of a team. Maybe a trio if we need to. And we've got decent tools. You don't even have to get near each other to do our remote collaboration, if that's a concern of yours. So, hey, Hector, thank you so much for donating those bits. Funding the Student Scholarship Fund here at the University of Michigan Dearborn, College of Engineering and Computer Science. That's so cool. Oh, you don't see the cool like animation. It does really like, if you're watching on Twitch, it like animates all those things. It's really cool. I'm gonna flip back so I can see it now real quick. Oh, you missed. Okay, it's not animating it anymore. But you also see here. I don't have the I'm not logged in. I have a new emote too, which is the coffee jitters. It's awesome. And I can do it on this one here. This is totally worth your time. So these little emotes. It's me drinking coffee but shaking, because I had a pot and a half of coffee already today. I got a night class tonight, so I'm going to keep drinking coffee. There we go. There's a little shaking coffee guy. All right, that was it. All right, so back to our examples then. So what I want to show you, when I go and open up my previous project, this was our week 1 project here. Do it in this window, and I'm going to flip back to the other repository, 2001. Winter 2022. One of the things we did is we started this branch. So all the changes that are happening are done on the branch called example. So any changes I make here are not going to be reflected in that main branch, because we want to take this unit of work and complete it separate from everything else that's happening, which is nice too, because if we're at an organization where you're working with more than one person, or you have like a decent sized team, hopefully a lot of stuff is happening, because if not a lot of code is changing, then I don't really know what your team is doing. But you want to be able to get your stuff done isolated from everyone else's changes, so they don't mess you up and you don't mess them up. So we're going to publish the branch, because right now github.com, the cloud repository, doesn't know about us. We only did this locally. So I'll publish my branch, and we had this silly little, hey, let's take a plus b. Enter two numbers, we'll add them together, and see what we get. All right, let me zoom that in a little bit. A little easier to see. I know, hopefully the dark and white isn't too bad with the lights on in here. All right, so we published the branch, and now when I go to repository view on GitHub, the main view, when you look at repositories, is always going to be the main branch. So I don't see, we merged the pull request. Okay, so did we get that far already last week? I'm just confused. All right, so we did merge that pull request. So we took all the changes and put them into week 1. So now if I go change back to the main branch, behind the scenes, all of the files will get swapped. So one of the things Git does when you change branches is it changes all of the files behind the scenes. So whatever snapshot was the latest on the main branch is going to be there. And I want to make sure I do fetch and see if there's any changes that my local repository doesn't know about that github.com, the cloud repository, does know about. Thinking real hard about that one. Okay, so we have everything latest and greatest changes on main here, which again, it's the same file. No problem here. So everything stable in main, it's accomplishing its goal, it's doing a plus b. Now, if I wanted to go and change this and say, oh, let's go get a third number now. Right, I'm going to make another branch. Let's do a new branch for add third number. We'll make our branch. So now we've isolated all of the work that's happening. We're no longer going to be changing main. Anything we change here will just be done on this branch here. We can add a third number. So we can have a value c as an int of an input, or a third number, and then we'll add all of those together, value c, and we can print all those out. I'm going to run it, make sure it works. Right? I'm pretty sure Python can add 3 numbers together, but never hurts to try it, because it's really easy to typo these things, especially with my terrible names here. If you had value A and value A and value B, and you missed C, right, you might miss out. So 1 plus 2 plus 3, you should get 6. I got 6. Feel pretty good, my code's going to work. So I'll come back to GitHub, and it's going to show me what has changed since the last snapshot. Well, what's changed is I added this line here, and then what used to be line 4 is now line 5, is A plus B plus C. So we're good. Okay, we like all those changes, so I'll make my commit. So this is add third number to add, or add third number, sure. We'll commit, publish this branch, and back out on the website here, my main GitHub repository, we're still looking at the main branch. So inside of main, nothing should have changed with the last commit, because I only changed what was happening in that branch. So here's the main version. If I want to go and change, I can say, oh, show me the add third number branch, and I'll see now this version. So you can flip between the two of them, right? Or as many different branches as you have. So everybody who's working on some particular unit of work can isolate their changes on their branch, and then when you're ready, you can go through that review process, right? Open the pull request, this compare and pull request thing. All sorts of shortcuts in this tool. It's amazing. We'll say, okay, sure, let's go and do this. I want to take everything in this branch, merge it into main. Create a pull request. So now I have /pull/to, right? With all of your classroom GitHub repositories, it automatically gives you that feedback pull request, so you don't have to go through those extra steps, which is nice. And then I can see files changed. Great, life is good. I see what's different. Leave any comments if we want. We're good to go. Now, I know this seems really silly for changing 2 lines. Yes, it is. But as projects get more and more and more complex, they're larger and larger and larger chunks. You know, the bigger thing you're taking on, it can get larger and larger, and there's more stuff happening behind the scenes for changes. So it's still the same process, but just at a larger scale. So ideally what we can do is we can break all of the problems down into smaller and smaller and smaller steps. It's one of my favorite terms. I think we talked about it last semester's functional decomposition, right? You're breaking down a big problem into smaller and smaller and smaller bits. Because it's easy to solve a small problem, harder to solve a big problem. So if I can break it down into small problems, I can solve one small problem at a time. There's a concept called minimum viable product. It's really interesting. It's actually rather difficult to do. Minimum viable product. The idea is you want to have the smallest piece of something that actually works and solves a problem, right? This is probably halfway decent here. Alpha.net, sure. I thought they had a nice picture. Where's that nice picture? I wanted the pretty picture. I want this. Okay, I just need the image search, I guess. So functional, reliable, usable, great design. I don't know, this sort of iterative process where you're getting a little bit of functionality that's going to work up and running. Yeah, oh, this was the good picture. Here it was. So when you think about minimum viable product, if you need to get to a car, it's not, hey, I build a tire, I build the axle and the wheels here, and then I put a frame on it, and then I put the hood on. And it doesn't work like that. The minimum viable product for some mode of transportation is, here's some basic transportation. Let's advance the transportation. So it's still doing something, which the goal was transportation here. We're evolving the product as we go. So again, that same idea, if I can take a big problem and break it down into smaller and smaller steps, if I can get something working, great. Right? If I haven't gotten anything working, I have no product. There's nothing I can deliver. So that's a common concept. And letting us do these sort of, we call them feature branches, let us get there. Right? I can do one small feature at a time. That way we don't have to tackle the entire thing. And you know, when you launch and all sorts of things, those are business problems that you have to work out as well. But that's all sorts of fun there. So when we get to larger scale projects, right, you can get little bits done at a time. On an individual project, you probably don't need to do any sort of branching like that because you're just going to keep on working. You can commit stuff. You haven't broken anything because you had nothing working. Right? There's nothing to break in main with making a branch. But as we get to looking at that group project at the end, if we can get some code in there, right, and then we can iterate, evolve on it, adapt it, make it a little bit better, add more features. There's like 3 different steps that we're going to try and tackle in that final project. We want to get the first step done, and then we want to add the second step, and we want to add the third step so we can get through the process of trying to solve this problem. I don't know, so last year, it sounds really silly, but it was kind of fun. We looked at the game of war, the card game, and the first thing we had to do was just make it play a game of war as a computer versus computer. So it just plays all the hands, sees which card is higher or lower. That was step 1. Once we had that done, then we wanted to be able to run that some number of times and calculate an average number of turns. So let me just shuffle up the deck and see how many times you have to flip cards over until someone wins. Because when I play against my kids, I feel like it takes forever for the game to finish. And it's not a very interesting game. Right? There's no strategy in war. I hate the game because I prefer strategy games. But the kids seem to think it's really funny. So sure, we found out, okay, this is the average number of times. If I play 100 games of war, shuffling every time, it took this number. That was step 2. And then step 3, we took this model here a little further. We said, okay, well, if I had 2 decks of cards, or 3 decks of cards, or 4 decks of cards, what's the relationship between the number of cards I have and how many turns it takes to finish? Is it some sort of linear track, or is it more of an exponential? And we found it was kind of exponential, which was interesting. So again, yeah, data science-y is a bit of a stretch, but it's taking us down that road of this is what we can do with code. We can take a real-world problem and write a simulation of it. I'm sure there's some math. Honestly, I have no idea what the math is to figure out how many turns it would take to win a game of war. One of our math profs could probably do it. That's just a guess, but I'm pretty sure they could figure that one out. But in a code, we don't have to figure it out. We can just make the computer do it for us. Try it a bunch of times. And that's one of the things we do in the world is we will simulate, hey, this is what it looks like. We're going to build our computer program to make it look like that. And then we're going to try a bunch of things. We can run experiments on it and see if we can find some sort of relationships. Later on, you'll learn about all sorts of cool libraries that let you automate a lot of that stuff. But we want to start with the basics and see, hey, can we do this by hand? There's another fun thing. Hopefully we'll have a chance to tackle it. There used to be, I think they still have it, there's a little web interface or web API you can use. We can send web requests out to some website and get stock market quotes. And we can get like 30 days worth of history for any given stock. And we can build a little stock market simulator. So we can say, hey, can I predict whether or not it's going to go up or down based on the last 30 days worth of history? It was complete crap. And I would not actually put real money in it, but it was an entertaining little project we did one time. So that's the kind of thing. It's still, this is essentially people's second programming class ever. So don't think we're doing anything super huge and amazing and big, but we're going to take those baby steps, work our way up into more interesting projects, and have something to show for it. So, and actually one of the former grad students who took the class a couple years ago, he ended up working at, where did he go? I don't even remember the name of the company, but they would do natural language processing on industry sentiment and press releases and sorts of news for companies, and then try and use that for predictive stock market analysis sort of things. Like, oh, hey, everyone's talking really excited about this new product this company's launching. Maybe it's a good time to buy some stock. That sort of silly thing. But apparently financial tech is real popular, if that's your thing. So all sorts of real fun things you can do. Yeah, and thank you. I think I've graded most of the syllabus quizzes that came in. Hopefully that was 3 points. We won't have a chapter quiz for right now. There's no chapter content. I'm not going to give you a quiz about any of the GitHub stuff. So the syllabus quiz is out there, and Lab 0 is out there, and the academic integrity quiz is there as well. Go ahead and take that module for me real quick. That should go relatively quick for you. Just hopefully reinforcing some of our policies here. Okay, so we'll get back to code here. I'm still on my branch. Right, we made our change for adding a third number. Great, we could go finish that out, merge our code if we wanted. So we'll go back to our repository, relaunch that one out. Nope, not Show Explorer, view on GitHub. We'll go back and do something slightly more interesting. Go to my pull requests, grab this one. There we go, yep, so merge. That's what happened last time. I deleted the branch. That's why I was confused. So deleting the branch gets rid of it on github.com. It doesn't get rid of it locally, which is a little bit unfortunate. There's some commands you can run to clean it up. Not really worth our time to do that. But it just keeps things a little cleaner on the central repository view. All right, so we're back in main. We've got all of our changes. Not yet. Once we fetch. There we go. Okay, so now it's saying my version of main is currently behind the cloud version. Right? I have changes that have to be pulled from the central repository back down. And this is that kind of workflow. So it's a push and pull. If you have changes that you made locally that the central doesn't have, you push them out. If the central repository has changes that you don't have, you pull them down. So it's a push and pull. Usually it goes real smooth. Every so often there's problems with it because you've changed a file that also changed, and Git says, I don't know what to do. Which version do you want to keep? It's actually relatively smart because it tracks things at the line level. If your change was like at the bottom of the file and someone else's change was in the middle of the file, it will change it no problem for you. But if you both happen to change the same line of code, then you have to manually tell Git which one you want to keep. So hopefully it won't be an issue for us. We'll talk a little bit more about some of that when we get to closer to that final project. And you can actually do a lot of these tools, or a lot of these workflows right inside of Pycharm, which is neat. Most IDEs now will integrate directly with Git, because Git is the most widely used source control tool. The reason I still like the GitHub desktop client is this tool is the same regardless of what language you're using, what computer you're on, that sort of thing, right? It's a common tool we can use. Sometimes the IDE ones are nice too, but it doesn't, they both work, so. All right, so we'll come back in here. Let's see. So this was just some silly example. Let's go through and do some quick reviews of our lists and dictionaries. Tuples are read-only lists, essentially. Those ones are all fun, but we'll build out a quick little list here, and let's just add some random numbers to it here. So if I want a list of numbers, starts off as a list. That's our square braces for lists. And then we want a bunch of random numbers here. I don't want to ask them to enter a bunch of numbers. We'll just pick some random numbers. So I'm going to say for number in range, we'll do, say, 100 random numbers. Right, range is going to give me 0 to 99, one at a time. You don't get the number you're ranging up to, so up to that. And then I want to take my list of numbers, and I want to append a random dot, we got to import random, sorry. So if we want to use random numbers, we're going to import random, get some random numbers, random, it's a rand int, right? Yeah, random.randint. Now, rand int is funky because it includes b. Excuse me. Really wish I had fluids. So if you're not sure, you'll Google Python rand int. Excuse me. Rand int is both included, which is really weird because no other languages do this. Our range function doesn't do this. Like, you almost never include that last number. It kind of bothers me that they do this. But sure, that's what it is. So if I want numbers between 1 and 100, I put 1, 100. This will be inclusive here, so inclusive of both values. Right. Occasionally I put comments in things, almost never. So I'm happy to put more comments in if it would be helpful. If you're going to go back and look at any of this stuff, just shout at me, hit me up in chat. I have a bad habit of not doing this because we like to imagine in the industry that the world is full of rainbows and unicorns, and everyone will write nice, pretty, clean, self-documenting code with variable names that everyone understands, and you can just look at it and in 30 seconds know what it does. I get that it doesn't actually always happen like that. That's not always the case, but that's the ideal we want to work towards. So any of our variable names should be nice and meaningful. If you just use A, B, C for things, I'm going to have no idea what it is. You might know for that couple of minutes you were working on it. You might even know for the entire day if you come back and look at it later. The next day, if you still remember, that's amazing and fantastic. Good for you. You've got a good memory. Eventually, you can't keep all of that in your head, and you're like, what did B stand for again? And then you'll kick yourself for not giving B a better name. Okay, so if your comment has to tell you what a variable is, you've named the variable badly. And some people still have it in their head that that's a good practice, and it drives me crazy. And I argue with all sorts of my colleagues about that when they say, no, comments are really good and useful, and you should always comment everything. And I just sigh. So I'll try not to. But if they're useful to say, like, hey, about a particular function, that's great. Happy to put them in here for you. Okay, so we'll add all those numbers. Now, to do things the hard way, we could find the min, the max, the average without too much trouble, right? So we could say the min value was going to be, I should even say minimum, right? Minimum value. We're going to say numbers of 0. We're going to assume it's the very first one until I know otherwise, right? And then we can say for index in range, and now I'm going to go from 1 to 100 because I don't need 0, right? I've already grabbed the first number, but now we can look at my list of numbers. And if the list of numbers at the index is, I'm sorry, this should be an if it's smaller than the minimum value, right, I now have a new minimum. Like if I give you a list of numbers and you are going to try and find the smallest one, you're going to kind of keep in your head what is the smallest, and if you see one that's smaller, you have the new smallest. Well, you're going to do that same thing. So then my minimum value will be the list of numbers at that index. Okay, we could also do the same thing with the maximum value. Maximum value is, I'm sorry, list of numbers here. That's why. List of numbers. Goodness. List of numbers at 0. So we can check, hey, if the list of numbers at the index is greater than the maximum value. No, it's greater than maximum value. Maximum value. Right, then we have a new maximum value. The list of numbers at the index. Okay, I'm using tab for that autocomplete, by the way, in case you're not picking up on those shortcuts. Try not to type things if you can help it. Be a good programmer. Be lazy, and I mean efficiently lazy, right? Don't do more work than you need to. And if you wanted to calculate an average, that we can't just keep a running average, right? We need a running total and then divide it by the length. So I'll have a total. We're going to start off at 0. I'm going to take my total. I'm going to add to it my list of numbers at index. And when I'm done then looking at every number in this value, every number in here, I can say now my average is going to be Average is the total divided by, I want the length of the list of numbers. List of numbers. Right, length will give us the length. And actually, I should have done that too. I should range from 1 to the length of the list of numbers, just in case we ever want to change the size up here. Right? I don't want to have to change this 100 5 different places. Right? So almost anytime you're using a list, use the length of it here, because the size of it could change. Okay, so now we have an average, and then we can spit out, we can print the min value was going to be the min value, and print the max value was going to be the max value, and print the average is going to be the average. Right, and again, this is doing the hard way, right? The fast way is you can just say, hey, min of some numbers in a list, right? We've got some built-in functions, min, max. There is no average, which is weird, but there's a sum here. So you can do min, you can do max of the list of numbers, and then you can do the sum of the list of numbers divided by the length of the list of numbers, right? So we don't necessarily have to do any of this stuff by hand, but if we didn't know these functions existed, it's essentially what it does. It does the same thing here, right? Picks the first one, looks at all of them, figures out which is the smallest. Right? It's just working with lists, looping through them here. If you don't like accessing things by index, remember we have the other for loop, which will take each item in a collection one at a time. Right? So essentially the same thing here, but we don't need to deal with index values. I can say for number in my list of numbers. List of numbers. And I can just use number then instead of my list at index. So the only downside here is it's going to take it's going to look at the first value more than once. And actually my total had a bug, none of you pointed out because you're too kind to me. Here, if we start at index of 1, our total doesn't have that first value. So total should probably start off at the first value, then we keep on adding to it. Otherwise we're going to be off when we try to average that. Not that we would have noticed, because 100 numbers averaging, we can't do that on our head. But that would have been a big problem for my average. And if we were to look at it and actually print these things out twice, we would have noticed that they didn't match up right. Right, so we can do it min, max, average this way. Is this too fast, too slow, boring? I don't want to spend too much time on some of this review, but just some basics, again, working through, trying to get back into the feel for Python syntax. Yeah?
You can add strings to integers.
So if you take anything and add it to a string, Python inside of a print, at least, is going to assume you want it as a string, and it will string concatenate, which says string and string together.
So it's only inside print.
Only inside print, yeah. If it might do it otherwise. Some string. I think it gets confused otherwise. Maybe it'll work. And we print some string. One of the times you want to use format, which is a little easier here. Let's see if that works for us. 1, 2, 3. Yeah, so this one here, it does fail on us. So you can only concatenate string to a string, not an int. So inside of prints, it's perfectly fine, because Python will assume you want something as a string when you print it. For here, then we'd have to, by hand, say, hey, I want this as a string so we don't crash. Okay, please turn this thing into a string to do the concatenation outside of a print command. Yeah?
That error is showing in line 33, which is in the print thing.
Oh, that wasn't print?
Yeah.
No, really?
So I think you have to do the comma.
Oh. You can comma separate. I thought we could concatenate. Is it not? Am I just thinking of I'm thinking of formatting then? That's unfortunate. All right. Comma separate. That is a bummer. And then this will give me extra spaces too. I don't need all these extra spaces then. There's a way to do this, or unless I'm going crazy. Yay! No, to do that concatenation, and we Google Python print string and int. I don't know. Maybe this will give us a hit. Oh, it does say you have to cast it. Is it if you do it backwards, does it work? if you do the integer first, I don't know, it's not important. As long as you get it to spit out, that'll be okay. One of the ways it's supposed to be smart enough, but that's all right. And then formatting is also super helpful, right? You can do your format strings to do all of your substitutions. Don't bother trying to memorize any of it. Just Python string format. I don't know, like number decimal places or something. So you can get it to automatically round for you to a certain number of decimal places is super handy with these given formats. Really, really nice. So we do a string dot format, and these sets of curly braces are substitution marks inside of here. Is a nice way to go about this. So if you want numbers to a certain number of decimal places, we'll take this one. So you can do the minimum value, substitute it in. We should actually do that with the average, right? We should do average, substitute it in. So 0.2f. And then we say dot format our particular numeric value here. Oh, excuse me. I need to go get some Coke in a minute. So if you use the format method of the string class, this is usually cleaner too. So this is going to be preferred. And this is just 2 values we're spitting out, not bad. But if your string has more than 1 value, if you have to comma separate a bunch of different things and add in quotes and stop quoting and add in numbers and variables and stop quoting, having a single string is much easier than to format into. Because you don't have to break up your string and have another one. So if we want to do this all in one line, right, we could do that. So we could say min was going to be, so that's probably a whole number, right? But so we just want the number, right? D for a number with, I always think of this as digits, not D for decimal places, D for like digits, whole numbers, F for floating point numbers, numbers with decimals. I hate the way they picked these, but sure. So we can do here's a decimal digits value here for the min, and then we can say the max is another decimal value, and then the average is that floating point, and we can format in all of those on a single line here. Sorry, it's just super dry. That's getting a little bit long. I'm going to try and bump it down one. See if it works out okay. Anyway, we already have that format, so we don't need that one either. Let's see if that looks any prettier. So let's give this a run. 1, 2, and 3. Oh. What? Oh, colon D, right? I think it's colons. It's not worth memorizing. Just go Google it. Yeah, colon for the D. And if you work with really big numbers, you can get scientific notation, if you like that sort of thing. Still confuses me to this day. I know it's not that hard, but like I just look at them and my brain says, no, this is too hard. So we can see our values here. So again, string formatting, this is probably nicer than doing it the other way. So the other approach then would have been min, comma separate, take the minimum value, comma separate, here's the max with a space and a dash in here because we have to make sure all of our spaces are in the right way. I think we get a space in between when you comma separate, and then we can do the max, and then say the average, and then add in the average, comma, sum, and that's not even rounded, so we'd have to do some other rounding here. So I think this one tends to read a little nicer than this one. And maybe that's just because I've been doing it longer, but formatting, anytime you're dealing with lots of substitutions, here's the single string that you can look at and see, and then, okay, I'm going to plug in a bunch of values, that sort of thing. And we should get the same output except for that rounding a little bit here. 1, 2, and 3. Yep. Oh, okay, it just worked out evenly to, we didn't have that many decimal places with our random numbers this time. And it's fun, but every time we run it, we should get different values, right? Because we're doing random values. Now it's 51, right? Pretty good odds. Oh, we didn't get a low of 1. That's interesting. But we did get our max of 100, the 100 values. That sort of thing. You all look super excited today. I'm sorry. So, all right, so that was our lists. We're working with dictionaries. Dictionaries are great. We do tend to abuse them a little bit in Python in that you can throw anything you want in there and have key and associated value. If your dictionary gets too complex, you're better off using a class, right, where you have named attributes, because you can have a single class be represented much easier than a dictionary with 10 different items. So we spent an awful lot of time last semester looking at like a basic gradebook, and you had the key was the student name, and then we had all sorts of variations of, well, what can I store for grade information? Was it individual values? Was it a list of other values? Was it a list of scores? And then a second list of other, total points and other possible points. And it got a little crazy, hopefully on purpose to let you see. Once we did it with a class, it was a little easier. Maybe it was easier. Maybe it still thought it was awful. But we can make that gradebook dictionary with our curly braces. And with our dictionary syntax, then you say key of Eric, right? And what value is associated with this? So what do we want to put in here? So if we just have, say, like letter grades, this is super easy, right? So then I can have a grade book. We'll add my son Jeb. He can take the class. Actually, he can't take the class with me, which is kind of a bummer. But I guess that makes sense, right? You probably can't easily objectively evaluate your family members. But I'm the only one who teaches this class. So I don't know what to do at that point. Maybe I just have to take a semester off or something, or it'd be 2 semesters off. That's a bummer. Anyway, so key of, add the associated value. When we get to dictionaries, right, keys must be unique. With our lists, we could care less, right? Things were put in a given position, they lived at a certain index. Dictionary keys have to be unique. Unique. So if I wanted to, I can't add a second Eric. If I try to say, hey, let's add a second Eric who has a B, it's really going to update my A to a B, and I'll be sad. And then the other Eric, I'm getting his grade and he's getting my grade, or he's not even getting my grade. We're just getting the last Eric's grade, which is either good or bad for us. Who knows? And growing up in school, there was always at least 2 Erics in every class of mine. So it turns out to be a relatively common name. Go figure. Right, so this just changes the value. Value. So if it doesn't exist, it adds. We'll add new value if the key doesn't exist. Right? Otherwise, it'll change the value, that sort of thing. If you try and get values out of a dictionary that don't exist, bad stuff happens. Remember, you get those key errors. It's over to say print, hey, the gradebook key of, and let's put Journey in the class too. One of my daughters. We put her in the class and see what score she got. If we haven't assigned her a value yet, we're going to crash. So we need to use some quick little checks here. 3, you get a key error. There is no Journey in the dictionary. So you can check real quick first. You can say, hey, if Journey is in the gradebook, now we can go do something, right? I can print out her score. Or we could even like ask for someone's name, right? We'll say, hey, a name is an input of, enter the name of someone to get their grade, or whatever we ended up doing, right? And we can check, hey, is the name in the gradebook? If it is, get the key of the name out. Oh, name, that was a bad copy paste. Name, key of name, right? So you could get Eric and Jeb out, anything else just won't happen, and then, our else could be print, they are not in the gradebook, right? And avoids erroring. So anytime we can avoid crashing is definitely a good thing, so we can get Eric's score back out, and it is going to be case sensitive. Remember, Python is always case sensitive. So uppercase E Eric is not the same as lowercase e Eric, which is also not the same as Eric with a K, or also someone in my subdivision was Eric with an A, A-R-I-C, which that was relatively unique actually, but he pronounced it Eric, which was still confusing for everybody. Thankfully in football, they called us all by our last names, which were much more unique. So that worked out pretty easy, although Chernesky is a mouthful anytime you're trying to shout at me. What doesn't matter? So, if you don't want the case to matter, you need to enter all of them as either upper or lowercase. Or you could check for both. Checking for all sorts of varieties is difficult because any combination of upper or lowercase in the middle of names, some people have multiple uppercase letters in their names, in their first names. That's actually somewhat common. Probably not as common as just a single uppercase letter, but lots of people have that, or some people have hyphens in their names. Some systems take hyphens out. So all of my children are Sovel-Chernetsky because my wife hyphenated. She's the last generation of Sovels. No one else has that name. We thought it'd be kind of cool to keep that around. I've got a brother with kids. I've got cousins with kids. So there's other Chernetskys around. So we're like, hey, well, all the kids will hyphenate. And at CVS Pharmacy, they don't put dashes in last names. I have no idea why. And every time I have to like spell the name out, I say a dash and like, oh, our system doesn't take dashes. Like all their techs know. But one time it was a new technician because they can barely hire anybody to work anymore because they don't want to pay them very well. And I'm trying to have them find this medicine and they keep like, oh no, it's not finding it. It's not finding it. Like, I've gotten it before. It's just a refill. Like look them up by date of birth. And they're like, oh, the last name doesn't have a dash in it. And I was like, oh yeah. They told me the system doesn't do that because they're stupid. Sure. But case sensitive. So if you were to be dynamic and put all of these in, like, hey, enter the name of someone to add to the gradebook, we could then lowercase it, right? And, you know, we could even ask them here, like, hey, if should we add it? They're not in the gradebook. Let's add them. What is their grade? And then we can have the grade as an input. Sure. And then we want to take our gradebook, and then we can say key of the name dot, is it too lower or is it just lower? Dot lower, well, lowercase. So we can either always lowercase or always uppercase. We just need to remember to be consistent with these things here. So how do we do all lowercase? Because why not? Deb, Eric. So we can add them. We can assign the associated value of grade for them with lowercase. And you can put this in some sort of while loop and you just keep on going. Run this as many times as you want. Keep on adding stuff to your gradebook until you're done. I think we did minimums, maximum, average. We did all sorts of silly things, all the basics as you're playing with this. But then you can assign them that way. You could go change them all, but that's probably a bigger headache to go take every key out of the dictionary, lowercase it, re-add it with the old value, because then you have to go delete all the other ones. But I guess we could do that if we wanted. So if we wanted to go through and loop, we could say for key in my gradebook, we can take the key lowercase. So we're going to take gradebook key of key.lower, and we can assign it the value of the gradebook of key, right? So take the key to lowercase as a possibly new entry. It might be the same one. If it already exists as lowercase, we're just going to update it with the exact same value. We haven't really changed anything, but that's fine. And then what we want to do is we need to remove that key from the gradebook. All right, so it was gradebook dot. Actually, okay, we need to do this first, right? So we want to get the, how about the grade is going to be the gradebook key of key. That sounds awful, but we can probably do that here. And we'll take our gradebook and we can remove, or is it delete? No, not remove. Here we go. Pop, sure. Gradebook.pop, the key out of the dictionary, and then re-add it in as lower for the given grade. If I were to pop it after the fact, if it already was lowercased, we'd be removing the only instance of it. So that'll probably fix it. What do you think? And then we'll just print the gradebook. So if I add these in as uppercase, Eric, Jeb, Eric again, we'll go through, we can add someone else. It already should be lowercased. We'll see what we get. 1, 2, and 3. All right, so name of someone, so we'll add someone who's not here. How we'll add Vivi, my other daughter, or one of my other daughters. Let's give her an A minus. We get Eric lowercase b, Jeb lowercase a, Vivi lowercase a minus. So it went through and it took the uppercase, lowered them, removed the uppercase versions, that sort of thing. And if you're not entirely sure what's happening, this is why we use Pycharm or a decent IDE, because we can debug this. Debugging is our friend. So over in the line numbers, I'm going to just click in there and get a big fat red dot. That's my breakpoint. Now instead of right-click run, I want to right-click debug. So blocked. It should be fine. We can allow access. Sure. Apparently I haven't tried to run this lately. Set allow. Should go. Okay, there we go. So first number 1, 2, and 3. Enter a name. We'll say Vivi again. How about an A minus? Okay. So once it gets to the line where the breakpoint is, it stops running. And I can see all of the variables here. I can see my list of numbers. I can see my gradebook. and you can expand anything that's a collection, right, to see the contents of it. So I see key of Eric, key of Jeb, key of Vivi. The associated values are strings. It's a little small on screen, sorry. I don't actually know how to zoom this one. But hopefully it's not too terribly small. And then we can step. So we get a couple options. So we get to step over, step into, and step into my code. Step into my code is fantastic. It'll avoid all the library functions. And then step out, we'll step out of a given loop or function back to where we were before. So most of the time we're going to step over. Occasionally we use into or out of. So I can just step over, and now I can see, okay, the given key I have currently is key of Eric. And then we'll get the grade. The grade value here then is a B, right? Because Eric, we gave a B when we updated to other Eric, because clearly this Eric wouldn't get a B. And then we're going to step again. We popped the key of Eric, uppercase E Eric out. Now my gradebook now just has Jeb and Vivi. And now we're going to go add the key to lowercase as a value associated with the value of the current grade, which was a B. And I can step. And now I see my gradebook now has Eric lowercase with a B here. Now the other fun thing you can do is I can go in here and I can change these values. So if I want to go say, okay, so now grade was Jeb's associated value, grade was A. Do I not? How do I get a chance to edit it? Is it not letting me edit? Okay, it's not letting me edit. I thought I could edit it in here. That's fine. I guess we can't edit it, but we can see what's happening. That's fine. We'll see it takes Jeb out. Now key of Vivi, right? That one doesn't actually need to change, but that's fine. And we can make it smarter if we wanted to, see if it was already lowercase, avoid all this sort of stuff, or just let it work. Yeah. This one?
The grade is not off. What exactly is that?
So this is, pop is to remove an item from a dictionary. So we're removing the key value pair, where the key is the current key we're looking at in the loop. So we're going to take each item out and re-add it as a lowercase version of itself, is what we're doing in here. Because that way we can go through and make sure they're all lowercase just in case. Not the most efficient thing in the world, but you know, if we don't know how the values got entered and we weren't sure that we were always lowercasing it the first time, we could go through and do it this way. That's one approach. Okay, and then I'll come back to GitHub, and we have some files. Main has been changed. Right, and oh, we did a decent amount of code. Look at that, 63 lines of code. Not too bad for a little bit of time here, right? So we'll say we added some lists and dictionaries, commit, and push. All right, awesome. I did it's not even bad here. When I did this formatting stuff here, I didn't cite my source. I don't expect you to take a number format and have to cite that as a source. Maybe I should have just as a good example. I'm sorry. So if you wanted to cite that as your source, right? Let me reopen that tab here. Which one was it? This one. Nope, this one. Keep reopening tabs. This one here, you could just take that whole URL, I don't care how ugly it is, and say, I don't know, number formatting from, drop in a URL. We have now cited our source. My apologies for not doing that better last time. But again, something ridiculously small like this, I don't care, right? And literally, this was in our textbook. I just didn't want to go have to flip pages because it's faster to Google than to go find it in the textbook, okay? If it's larger than that, yeah, let's just cite our source. We'll get into the habit of that good practice here, if that's okay with you. Does that make sense? So generally, anything out of the textbook, you can just put like book, and I'm cool. If you want to give you a page number, even better. But essentially, book is fine. Like if that was your source for something you did, cool. I'm good with that. I'm assuming we use the textbook for reference, right? Because if you're going to spend a bunch of money on a book, hopefully you're going to open it. Right, that sort of goes for that. Anything else online, right? Just drop the URL in, say I got it from here, and we're okay. Again, you shouldn't be able to Google entire solutions unless I screwed up. So you might have like, hey, how do I find out if a number was prime? Sure, we'll cite a source for that. That's no big deal. You don't need to reinvent the wheel, okay? more of what you're doing, right, is taking all these tools and techniques and things that we've learned and applying them to solve problems. They're not even interesting problems. We're just solving problems here, trying to see, okay, I know how to do something now. Can I use it to solve another problem? Okay. All right, and then I can commit that as well. Look at this. Cited my source like a good boy. Excuse me. And commit and push. All right, so for tools for workflow, again, we don't need to be doing the branches ourselves right now. I want to show you that's how that works. The GitHub classroom workflow makes that nice and easy. Oh, Bay wants us to tell me, not us, us is a funny word, to tell a dad joke. Thankfully, I come prepared. I got this amazing pack of jokes for the holidays here. I have a dad joke for your friends. So if you're watching online, you can get points just for watching on, like, their channel points. You can use them for silly things like dad jokes. Because if you're listening for another hour, 15 minutes straight, you just get really tired. So we got to take a break every now and then. Okay. Why do melons have weddings? Because they can't elope. All right. Oh, you knew that one? Okay. Did you hear about the restaurant on the moon? Great food, no atmosphere. That was I like that one. That's a pretty good one. So, all right, I think that's about all we got for today. So on Tuesday, again, we'll pick up the lab. We're going to do Unix stuff because really there's nothing again to practice yet. Haven't really gotten anything new. Good chance to work with Unix. I'll let you know. For sure, it'll work with the VPN, but if it'll work without, I'll let you know. So I'll have some directions for that. It's not the worst thing in the world. I think I even have it over here. Yeah. This is just a rinse and repeat. We do this lab every time because nothing else needs to change. So I should give you this Word document. You go through a bunch of steps. This one, unfortunately, you don't turn in a link to github.com because your code isn't on github.com. Your code is on the Unix server. So you turn in screenshots, and I feel terrible about it. But I don't really have a better way. So you'll go through and you'll do stuff using Unix commands like mkdir and pwd and ls and all sorts of fun commands here. I will say it does pay to get familiar with the command prompt or the shell or bash in Unix. It's a very powerful tool. You don't always need to use it, but when you do, if you're a little bit more familiar with it, it's super handy and it looks like magic when you get to do all sorts of fun things. So you take a screenshot, right? Put it in, you just paste it right into this. You'll just make a copy of this and just drop your screenshots right in here and upload this back to Canvas. We'll do hello world as hello, and then we're going to transfer that file using Winscp, which I'm pretty sure Winscp is free. Let me double check that. Yeah, free client. So you can use this as a file transfer tool to connect into the Unix server. Your H drive, when you log into the computers, is actually available when you log into Unix as well, which is kind of fun. So you can transfer files back and forth that way. It's interesting. Make new files and use Pico or VI. Pico is actually much easier to use, but VI, there's a certain amount of, I don't know, it's notorious for being, it's not awful, it's very particular. There's certain people, if you get good at using VI, you can be ridiculously fast at doing anything in the text editor. It has all sorts of amazing shortcuts, and there's some guy online, I forget, it's the Prime, I don't know, I follow him every now and then. He does things in VI, and because that's all he does all day long is work in VI, he can just go nuts. It is super fast. It's a really handy tool, but it's kind of crazy. So at the end here, there's a little shortcut for how you do things in VI. In VI, there's insert mode and command mode, and you have to switch between the two, which is the most confusing things for people. So commands like :Q for quit are commands you can run. That's the only way to get out of VI once you launch VI. You have to go into command mode and run :Q. So there's whole jokes and memes online about how you have to quit VI and things like that, just because it's so awful. And awful is the wrong word, I'm sorry. It's unfamiliar. It is very unfamiliar. So once you learn it, it's great, and you can laugh at everyone else who doesn't know it. That sort of thing. So this is what we'll spend our time in on lab on Tuesday, and then we come back, and we actually then finally get into content. We open up our book for the first time. We take a deep dive into object-oriented programming. Service unavailable. Service unavailable. I broke it. Oh, it's just downloading it now? Okay, sure. We'll get into chapter 2. We'll do all things object-oriented programming. Tuesday, Thursday, we'll talk about the first project that you'll have to tackle using object-oriented programming, using inheritance, all sorts of fun stuff, and we can go from there. Okay, so we'll do 2 weeks for every project. We'll have a project every 2 weeks. We'll take a break for the midterm week, so that'll be the only thing you have to do. Then we have spring break. We come back, 2 more projects, and then the final project, and that is the winter semester, believe it or not. So we're already looking at the end of April, even though it's January 13th. So, okay. All right, well, that was fun. Thanks, folks. I will see you Tuesday then. If you got anything else, let me know. I'll be around. And I'm not so jittery now. I think the coffee has worn off from the drive. So I don't need the little bouncy emote here.